right into a problem. And this is where it's going to be a little nicer and a little less tedious. I want us to list all possible rational roots. Then find all roots. When I say all roots, do I mean just the rational roots? No, I mean rational, irrational, and also imaginary. That all falls into all roots. So if it's a rational root, I have to find it. If it's an irrational root, I have to find it. If it's an imaginary root, I have to find it. So I want to find all roots. And we're going to have p of x is equal to 2x to the fourth power minus 7x to the third power plus 8x squared minus 7x plus 6. So the first thing I want to do is list all our possible rational roots. So we call this P over Q. And remember, the P is the factors of our constant, and the Q is the factors of our leading coefficient. So the factors of our constant are going to be plus minus 1, plus minus 2, plus minus 3, plus minus 6. And the factors of our leading coefficient will be plus minus 1, plus minus 2. Now that I've listed out all the factors of the constant and all the factors of the leading coefficient, what do I have to do now to get my list? Ariana. Good, you got it. Pair every numerator with every denominator. So when we have our P over Q, our possible rational roots would be plus minus 1 over 1, plus minus 1 over 2, plus minus 2 over 1, which is just 2. Should I write plus minus 2 over 2? Should I write that down? No, because what is 2 over 2? 1. Isn't that already written? So I don't need to write that again. Now we're going to have plus minus 3, plus minus 3 over 2, plus minus 6, and then 6 over 2 is 3, so that's already taken. Now, last class, this is what was miserable. What were we doing last class to find the roots? Yes. What were we doing? We were guessing. We were guessing from our list and then doing what to see if it was true or not? Synthetic division or synthetic substitution. Exactly. So we would take this root, we would guess a root, we'd put it in for synthetic substitution, and if the remainder was 0, then it was a root, right? And we'd have to do this until it came down to a degree of what? 2. And then once it was down to a degree of 2, what were we able to do then? Factor or use the quadratic formula. How many roots do I need in total here? I need 4. So this is where Desmos really helps us. So now we have our list of our possible rational roots. We're now going to go to Desmos. So let's all go to Desmos. We're going to go to our graphing calculator. And now we're going to enter in this function. So we have 2x to the fourth power. Do you guys know how to enter in that fourth power? You do the little up arrow, so you press shift and number 6. Yes, we know how to do that? Okay, so we have 2x to the fourth power minus 7x to the third power plus 8x squared minus 7x plus 6. How many roots should we have? 4. How many are shown? 2. What does that mean for the remaining 2? They're going to be imaginary. Is that okay? Absolutely. Because all I need are two rational roots because I could do the synthetic and get it down to a degree of 2, and then that will help me find the imaginary roots. So let's look. So the first one is 1.5. Was there a number in our list that was the equivalent to 1.5? Yeah, a positive 3 over 2. And then we have 2. Was 2 also in our list? Yes. So now that's what we're going to do. We're going to use the synthetic substitution twice, one time with 3 over 2, and the other time with 2, get it down to a degree of 2, and then solve. So let's do it. So we know for our roots to start, we know x will equal 3 halves comma 2. Do we agree? That's 2 of the 4. All right, so now I'm going to use this synthetic substitution. I'm going to start with 2, so I don't have to do a fraction right away. And I'm going back to my polynomial, and I'm just making sure that this function has everything I need. Is it in descending order? Yes. Is every exponent accounted for? 4, 3, 2, 1, 0 constant? Yes. So this is in a good format. So now we're going to have just our coefficients: 2, -7, 8, -7, and 6. Bring down the 2. 2 times 2 is 4. We're going to have a -3. -3 times 2 is a -6. 2 times 2 is 4. -7 plus 4 is a -3. -3 times 2 is a -6. What if that last column wasn't a 0? What would that tell you, Leo? But wasn't it a root? I mean, if it's a root, then it's going to be a factor, right? Then we're going to get our factor from there. It means something went wrong somewhere. Maybe I looked at the root wrong. Maybe I entered it in wrong. Maybe I did the synthetic division wrong. But it means I did something wrong somewhere. So what should we do? Go back and check again, see what I might have done wrong. Because it showed that it was a root in Desmos. So either I typed it into Desmos wrong or I did synthetic wrong. Something went wrong somewhere if this doesn't come out to be a root. Violet. No, because the Desmos is accurate. It shows you that it's a root, so it has to be a root. So the only way that would happen is if something went wrong. Desmos won't be wrong. All right, so now what do? Now I'm going to use the 3 halves. Do I go back to the original coefficients or do I use the new coefficients? The new coefficients. We use the new coefficients. So we're 2, -3, 2, -3. Bring down that 2. 3 halves times 2. Isn't that 6 halves? But what's 6 halves? 3. -3 plus 3 is 0. 0 times 3 halves is 0. 2 plus 0 is 2. And then once again, 2 times 3 halves is 6 halves. And 6 halves is 3. So now these are the coefficients for my newest factor, actually. And what degree am I starting this off at now, since I did synthetic substitution twice? 2. So now this is going to be a 2x squared plus 0x. Do I need to write plus 0x? No. Plus 2 equals 0. There's no factoring this. There's no point in using the quadratic formula. What can I do here? I can just solve. So I'm going to have 2x squared equals -2. Divide by 2. X squared equals -1. Square root both sides. X will equal plus minus I. Does this make sense that plus minus I will be my remaining 2 roots? How does this coincide with my Desmos graph? Violet? Because it's 2 imaginary numbers, so we wouldn't see them in our Desmos graph. So this makes sense. So go back where we listed our roots: 3 halves, 2 plus or minus I. Desmos makes it so much easier than the guesser check. We got some. All right. I want you guys to try this one on your own. Same directions. We're going to list all possible rational roots, and then you're going to find all roots. F of x equals 64. I'm sorry, not 64. 6x to the fourth minus 29 x squared equals 5x to the third minus 25x plus 5. Before you do anything, what should you do? Before you do anything, what should you do here? It should be the first thing you do. Before you do P over Q. Charlie? Same side. Good. Oh, sorry. I should have never put f of x equals. Sorry. That's a little confusing. All right. We want to move everything to the left side. You want to move everything over to the left side to make it equal 0. So when you moved everything over, this is how it should have looked. And your P over Q should be plus minus 1, plus minus 1 over 2, plus minus 1 over 3, plus minus 1 over 6, plus minus 5, plus minus 5 over 2, plus minus 5 over 3, plus minus 5 over 6. Okay, so these are your possible rational roots. What should you do now? Now that we got our list of possible rational roots, what should we do now? Go where? Go into Desmos. Exactly. We're going to go into Desmos. Charlie, can we silence it?
I silenced it. Oh, was your phone bleeding? I shut it. I silenced it.
Okay, so here we are. Let's see. It looks like we have four roots. Does that seem the same to you? It looks like four roots. Okay. So I have a negative 2.23607, and that decimal actually keeps going. If this decimal keeps going, is this a rational root? No. So that's why none of the numbers we have listed actually matches this. But it's still showing up on my graph. So what does that mean? It's not a rational root, but then the fact that it's on the graph means it's not imaginary. So what does this root have to be? Lily? Irrational. This has to be an irrational number. Am I going to find an irrational number in my list? No, so I can't use that. So I don't know what this is. All right, this next one, 0.33333, this is a rational number. How come even though it keeps going, this is rational, but the other one that didn't keep going was irrational? Charlie? In a pattern, exactly. If the decimal keeps going in a pattern, it is a rational number. So what number is the equivalent to 0.3333333? Sorry, say it one more time. 1/3, you got it. So we know 1/3 is one root. Then we have 0.5 is a half part of that list. Yeah. And then this is, again, an irrational number that will not be part of my list. But the fact that I have two rational numbers, that can help me find the irrational numbers. I will tell you on the test, if you write negative 2.23607 as an answer, I will not take it because this is a never-ending decimal and I don't want the decimal. So I need the radical that's the equivalent to this decimal. So what are we going to do to find the radical that's the equivalent to this decimal? We're going to use synthetic twice and then solve. So we have our roots. We have x equals 1/3 and x equals a half. Do you want to start off with the 1/3 first or the half first? 1/3? Sure. Let's start off with the 1/3. And we have our coefficients 6, -5, -29, 25, and -5. All right, so we have 1/3 of 6 is 2. -5 plus 2 is a -3. 1/3 of 3, -3 is a -1. That brings us to a -30. 1/3 of -30 is a -10. 1/3 of 15 is a +5, which brings us to 0. Now we got the 1/3. Now we're going to use the half and our new coefficients. Half of 6 is 3. Half of 0 is 0. Half of -30 is a -15. So now that I've used synthetic twice, I was originally at a degree of 4. Now we're at a degree of 2. So now I can say 6x squared plus 0x, no need to write that 0x, minus 30 equals 0. So we're going to have 6x squared equals 30. Divide by 6. X squared equals 5. So what does x equal? Plus minus root 5. And there's our remaining two radicals. If you were to type in the square root of 5 into your calculators, I guess we could go to Desmos and do that. How do I get back to my, here, let's leave site. So if I just want to do the square root of 5 and enter, How do I get my answer here? 2.236. Isn't this the same decimal we had seen there? So there we go. All right, let's do another one. So again, we want to find our possible rational roots first. So I'm plus minus 1, plus minus 3, over plus minus 1, plus minus 2, plus minus 4, plus minus 8. And now we're going to pair every numerator with every denominator. So there is my complete list of possible rational roots. Yes. Scroll back to the previous problem.
Yeah. So,
Oh, this one? All right, so now let's go to Desmos and see which of these will work. How many roots should we have? Shouldn't we have 4 roots? Okay, here's one, -3. Was that part of our list? Oh, wait, guys, did I type in the wrong one or did I type in the right one? Was 3 part of my list? Yeah, 3 was part of the list. Okay, thought I typed in the wrong one. All right, so we have -3 as part of our list. We have -1/2, that was part of the list. And we have +1/2, which is also part of the list. How many is that? That's only 3. But do you guys see this one? This half? Do you see how it doesn't cross the x-axis and then come back up? How it hits the x-axis and bounces off? This is what you called a double root. This means that this root counts twice. So when a function hits an x-axis and then pops right back up, meaning it doesn't cross the x-axis and then come through again, it is called a double root, which counts as 2 roots. So we actually have 2 roots here. So we have 4. So the way we would do this when we list our roots, we're going to have x equals -3. We have x equals 1/2, and then wasn't the positive half where the double root was? So then when you write down the half, what you have to put next to it is dr, meaning it's a double root. So I know that you know there's supposed to be 4 roots, but this one counts twice. And what this would look like if we were to factor it, it would be 2x plus 1 quantity squared when we were to solve equal 0, meaning this 2x plus 1 counts as two factors. That's what this means. 2x plus 1 twice. That's what the double root means. Have I lost anybody with that? Leah, what's wrong? So for example, let's go to a simple problem, Leo. Let's say I have x squared plus 2x plus 1 equals 0, right? If we were to factor this, wouldn't this be x plus 1 plus another x plus 1? So our only solution here would be x equals, no, x would just equal -1. But how many solutions am I supposed to have? 2. You're supposed to have 2 solutions, but we do. It's just this -1 is counting twice, one from each of these factors. It just happens to be that those factors were the same. Okay, so for this next one, I want us to, new directions here. I want us to estimate any real roots in the given interval. And we're going to have p of x is equal to x to the third minus 3x plus 1 in the interval from 1 to 2. So am I looking for all 3 roots? No, I'm looking on the roots just in the interval from 1 to 2. Now, when I give you this interval from 1 to 2, what is this interval on? Is it the domain on the x-axis that I'm giving you, or is it the range on the y-axis that I'm giving you? Charlie? Good. This is the domain. This is the x-axis. So let's go to Desmos. And we're going to have x to the third minus 3x plus 1. But I'm just looking on the interval from, what was it, 1 to 2? Yes, was it 1 to 2 that I said? Interval from 1 to 2. Since I'm only looking on the interval from 1 to 2, do I care about this 0 right here? No. So I only want the interval from 1 to 2. And it says round, meaning you're going to get a decimal. That's okay. I'll let you give the decimal and round it to the nearest hundredth. So I'm going to look here, and the decimal we get is 1.53209. So we're going to go back, and we're going to write, we have x equals 1.53209. But now I want to round this to the nearest hundredth. That's the second number after the decimal place. So we look at the number after that. If that number is 5 or bigger, we round 1 up. If that number is less than 5, I don't round down. What do? Keep it the same. So x will equal 1.53. That is the only root on this interval. Completely different than what I was asking before. Was I asking for P's or Q's here? No, I just want you to use Desmos, and I want you to round in the given interval. That's it. All right, we are done for today.